All right, so I'm going to work our equations test review. I'm going to work it on a separate sheet of paper, especially with the equations. It just makes it a little bit easier sometimes to keep those things lined up if I have some lined paper. So I'm going to start with number 1. We've got 6c plus 4 6/100 equals 10. So I'm going to draw my line, and our first step is to make sure it's an addition problem, which it is. Second step is to get rid of the constant, which is the number without the variable. So we got 4.06 is our constant, and the way that we get rid of the constant is to add the opposite. And whatever we do to one side, we do to the other. So these cancel, and I've got 6c equals, and 10 plus negative 4.06. Those are actually on different teams, so I've got to subtract or battle those. And I need to make sure and line up my decimal. So this is a big mistake that I did see some people making. I got to borrow all the way over from the 1, so this becomes a 9, and a 10. So 10 minus 6 is 4, 9 minus nothing is 9, and 9 minus 4 is 5. So I've got 6c is 5.94. So to get rid of the times 6, I do the inverse, which is divide by 6, and then I need to do some division. So we've got 5 94/100 divided by 6. And so what we're going to have, 6 goes into 5. It doesn't, so I'm going to put a placeholder. 6 goes into 59 9 times, and I get 54 with 5 left over. I'm going to bring down my 4. 6 goes into 54 9 times. So that's exactly 54, and it leaves me with nothing. So I'm going to get my decimal, I'm going to bring it up and leave it right there. So these cancel. We've got c equals 99/100. You could also put the 0 in front of it if you wanted to, and it is the exact same. All right, so number 2, 37 plus 8x equals 33.5. All right, so I'm going to draw my line. Same thing, it is an addition problem. So now to get rid of the constant, I'm going to add a negative 37. These guys cancel, and I get 8x equals 33.5 plus negative 37. They are going to have to battle because they're not on the same team. So we got 37 minus 33.5. I do have to line those decimals up, and I am going to have to do some borrowing here. So we get, that's a 6. So we get 10 minus 5 is 5. 6 minus 3 is 3. So we have 8x equals 3.5. So to get rid of the coefficient, you do the inverse. So the inverse of times 8 is going to be divide by 8 on both sides. These are going to cancel. And now I just need to work out that division problem. It is kind of a yucky one, so if you'll stick with me if you want to check your work. We've got 3.5 divided by 8. So 8 does not go into 3. It goes into 35 4 times. And I get 32 with 3 left over. So since we already have a decimal, we don't have to add another one, but I'm going to add a 0, bring it down. 8 goes into 30 3 times, and I get 24. And I have 6 left over. And I'm going to add another 0, bring it down, and 8 goes into 67 times, and that's 56 with 4 left over. And this is the last one. 8 goes into 45 times, and that actually ends that decimal. So because there's nothing out here to jump, I just move it straight up, and x is equal to 0.4375. Definitely not a super friendly number, but that's okay. Okay, so number 3, we got 40x plus 20 equals 160. So again, we get rid of the constant first because it already is an addition problem. So to get rid of the 20, we're going to add a negative 20, and whatever I do to one side, I do to the other. These guys cancel, so I get 40x equals, and 160 plus negative 20, that definitely gets me 140. All right, so I've got 40x equals 140. So I do need to do some division. So I'm going to divide by 40 on one side, divide by 40 on the other. And if you know the zeros trick, technically they both have a 0, so I can mark that out. So really what we're doing here is 14 divided by 4. So 4 goes into 14 3 times, and I get 12. And really, if I wanted to leave it as a fraction, I could. So there's 3 whole things with 2/4 left over, or that simplifies to 3.5. So if you wanted to do that, you could. Some of you may have added a decimal and added a 0 right here. So I would say that x equals 3.5, or if you wrote 3.5, that would be correct as well. So on number 3, you could get x equals 3.5 or x equals 3.5 because those are equivalent. Number 4, it's 2x plus 10 equals 16. So I'm going to add a negative 10 to both sides. So I've got 2x equals 6. Those guys battle, and you get 6, and divide by 2 on both sides, so x equals 3. And remember, one of the things that we said we can do is check our answer. So if I really wanted to, I could plug it back in over here. So 2 times 3 plus 10. Well, 2 times 3 is 6 plus 10, and then that gets us to be 16. So it gets us to what we need. So there's a great way to check our answer. Let's go to the number 5. There's a model. Let's see if I can get this closer up here. So each one of these we talked about in class with models. Those are the x's. And each one of these is a -1 because it is shaded. Okay, so the first thing that we have to do is just to write the equation, and from there, then we can just solve it. So we've got 3 x's. It's going to be 3x and 2 -1s. So 3x and -2. And that's all equal to, and over here, we have a -8. So 3x plus -2 equals -8. And one of the things we talked about in class was once you have written that equation, you don't need the model anymore because we know how to solve really well. So same thing, make sure it's an addition problem, which this one happens to be. Most models would be actually to get rid of the constant, you're going to add the opposite. So to get rid of a -2, we add a +2 to both sides, and those guys cancel. So we've got 3x equals -8 and +2. Those are not on the same team, so they battle. So we get -6. And then to get rid of the coefficient, I divide by 3. So x in this case, and this is a really important step right here. -6 divided by +3 is -2. And some of us are, in class, we're dropping those negatives, so we need to make sure and not to lose our negative in that question. Number 6 is also a model. It's basically saying that this part is equal to this part because they're the same size. We did look at one of those in class. So this says that 2 and 3x, so 2 and 3x, is the same size as 8. So this one looks really similar to the one above it, and that was not done on purpose, but it does look very similar. So to get rid of the +2, we add a -2, and so we've got these guys that cancel. We've got 3x equals 6. Divide by 3 to get rid of your coefficient, and so x equals 2. So not the exact same answer, very similar problems. So hopefully you've done pretty well on the first part. The second part has a little bit of the word problem scenarios with it, so we're going to read through it. It says, today's temperature is expected to reach 13 degrees Celsius. Adrian uses the equation 117 equals 5x minus 160 to convert this temperature degrees Fahrenheit. Basically, it says, what is the temperature in degrees Fahrenheit? Okay, so basically, let's say that we've got 117 equals 5x minus 160. Okay, so from there, we're going to go ahead and solve. And one of the first things on our flow chart says to make sure that it's an addition problem. So this one does not look like an addition problem. It does have a subtraction sign, so I'm going to grab a different color. So the very first thing, hopefully, that you would do is you would do leave, change, opposite. So you leave the first term, change subtraction to addition, and I need the opposite of 160, which is -160. So from there, that's really my new problem. and I can get rid of the constant now, which is negative 160. So to get rid of the negative 160, I'm going to add a positive 160, and these guys cancel. So on this side I have 5x, and then 160 plus 117 is 277. Okay, so then from there I need to do the last step, and that's to get rid of the coefficient. So to get rid of a times 5, I divide by 5. Okay, and I can probably come out here and do that. 277 divided by 5. 5 goes into 2, nothing. 5 goes into 27 5 times, and 5 times 5 is 25. Same thing, bring down your 7. 5 goes into 27 5 times, which is 25. And I have 2 left over. So I could do one of two things. I could change it into a mixed number, but if I look back over here at my answer choices, those are all in decimal form, so I definitely want to keep that in decimal form. So I'm going to add a decimal, add a 0, and 5 goes into 24 times. So 55.4, and that represents the degrees in Fahrenheit, which is what we were trying to find. All right, so number 8 says Marco has a $90 gift card to use at Academy. He buys a sweatshirt for $20, and it says A, so that means he's buying one of them, and several pairs of running shorts for $16 each. I'm really hoping that if you heard the each, that you already kind of have a spark in your mind. And this is something that we did in class, co and con. Co stands for our coefficient, and con is going to stand for our constant. So hopefully you have already seen that 16 is going to be your coefficient, but let's just check it. Which equation can be used to find P, the number of pairs of running shorts? Well, running shorts definitely matched with 16, so our coefficient is going to be 16, and our constant is going to be 20. So really all we need to do is look at these answer choices and see which one has the correct choice. So this one has 20 as the coefficient. So that's not what we put down, so I'm going to put that that is not the correct answer. This one says that 16 is the coefficient and 20 is the constant with a $90 total. I think that might be it. This one right here, it has both of the numbers, but if we were to distribute, this would be 16p plus 20p. And that's definitely, we don't have both of those as our coefficient, so C would not be the correct answer. And this guy right here says that 16 is the coefficient, but it also says that 20 is over here with the total. And so if I were to rewrite this, it would say 90 equals 16p minus 20. And we're not actually taking the $20 out. It's not like a coupon or something. He's actually spending the $20. So D would not be the correct answer. Our correct answer for that one would be B. Awesome. So number 9 says graph the solution on the number line. So we've got 3.5x minus 0.8 equals 2.7. It looks really ugly. It's really not too bad once you get going. So definitely this is going to need some LCO. Leave, change, opposite. And again, we just do that to prevent careless errors, and it really helps us when we get to inequalities. To get rid of the constant, we add the opposite. So to get rid of a negative 0.8, we're going to add a positive 0.8. Okay, these guys cancel. So we got 3.5x equals, and 2.7 plus 0.8, looks interesting to me, is 3.5. Well, look at that. So it's really not as ugly as it looks. To get rid of a times 3.5, we divide by 3.5 on both sides. So x equals, and 3.5 divided by 3.5, no, it's not 0, it's 1. I can hear you guys now. So x equals 1. So basically this says graph the solution. All that means, when we talked about this in class, is you're going to take your answer and you're going to place it in the correct spot on the number line. So our answer is 1, so we just put a dot at 1. Pretty simple. All right, this last question is one of those where it gives you the equation and it's asking you which one of these is the correct word problem. So I would really encourage you on each one, and we even kind of did some of these in class, co and con on each one, because if they don't have the correct coefficient, or the correct constant, I can already get rid of the answer choice as it is. So this one says Ezra buys 8 pounds of peanuts and 5 pounds of almonds. He spent $35.50 total. What is the price per pound of peanuts? So this one has 8 as the coefficient, and it has kind of 5 maybe as the constant. Well, in our original equation, the coefficient should be 5, so it's not going to be correct. So I'm going to say A is not the correct answer. So pretty easy. Once I found something that doesn't match, I mark it out. B, Kate runs the same number of miles every week. On Saturdays, she runs 8 miles, and she does not run on Sundays. In 1 week, she ran 30.5 miles. That means Monday, Tuesday, Wednesday, Thursday, Friday, she's running a certain number of days. So it says, how many miles does Kate run each weekday? Well, we know there are 5 weekdays, and this each word tells us that that's going to be our coefficient. So that means 5 is going to be our coefficient. And our constant is going to be the number of miles that she runs, without, not on the weekdays. So it says she runs 8 miles on Saturdays. So this one seems to have the correct coefficient. It seems to have the correct constant. So I'm going to put maybe a little question mark. And I always like to check all of them. Killian bowls 8 games. She rents shoes for $5 and she spent $30.50. How much does each game cost? Again, 8 games, and each game costs $8. So this one has the coefficient as 8 and the constant as 5, and that's not what our equation should look like. Sherry bought a ticket to a baseball game for $5 and a hot dog and a drink for $8. She spent $30.50. How much does she spend on parking? This one really just doesn't make any sense at all, because it would be she bought a ticket to a baseball game for $5 and a hot dog and a drink for $8, and she spent some money on parking, and that all equaled $30.50. So there's really no coefficient. There's really no coefficient in this one, because it's just asking for one piece of parking, so this guy would not be our answer. So we have reasoned through, and we know that our answer is B. So if you've gotten to the end of this video, so awesome for you. That is great. Hopefully you checked your answers and you had most of them correct. If you did get to the end of this video, I'm going to give you a little bonus for getting to the end and listening to the end. So if you will, put like put a little, we'll say star, okay, and circle it at the bottom right-hand corner of your paper. Nobody else will know. It'll be our little secret. And that will just tell me that, hey, you watched all the way to the end and you checked all your answers. Hopefully you guys are super prepared for this test. I know you guys have been working hard in class, so I will see you soon. Good luck on your test.